how many cards there are, different types of suits and things like that. Introduce them to you so you understand when we start asking questions of how many possible ways can you get 4 aces? How many possible ways can you be dealt a full house? To understand what the lingo means for 5-card poker hands is kind of usually what we deal with a lot with probabilities. That way you guys get familiar with it, because not many of you have played cards and or have played poker. So, what's that? You don't play with those. So let's just go through this. We know we're going to talk about deck of cards. In a deck of cards, your standard deck of cards, you will have 52 of them. I'm sure some of you might have had a grandpa or an uncle or somebody said, "Hey, do you want to go play 52 pickup?" And then they would just spit these out and say, "Hey, there's 52, pick them up." That was an old. No. So you have 52 cards. There are. We do not worry, you guys. There are jokers in the deck of cards. There's usually 2 of them in there. You never play with them. I don't know. Google it. There are what we call 4 suits. The suits are. We have the heart, the diamond,
That's close. Sorry, you're
Once again, I have never once said that I am an artiste, nor will I ever try to play one on TV. What I did here, we have diamonds, we have hearts, diamonds, spades, and clubs. Excuse me.
See, I said clovers.
I drew them in their colors. Half the deck is red, the other half is black, which means that you'll have 26 red cards and 26 black cards. Within each suit, there are 13 cards. There's 13 of these, 13. Okay. You have your 2 through 10, Jack, Queen, King, and an Ace. Now, these 3 are called face cards. Because, quite literally, they have faces. Not to be confused with the Rod Stewart, Jeff Beck, and company band, The Faces. Stretch to get to that one? Just stay with me, it'll be fine. See, did that one right there? Faces, Stay With Me, it's a song. Come on, that was a stretch. But I brought it back by saying stay with me.
That was decent.
Ronnie Wood is in that one, from the Stones. So it's my first rock concert, in case you guys care. 1989. So what happens here when we're talking about deck of cards, you can do a bunch of different things. We can count hands, we can talk probability about certain things occurring. A lot of times what I want to do with this chapter is I want you to think of order not mattering, because we're just making combinations. If I want to just think of how many different ways that I could get dealt 5 cards, the order in which a card comes up doesn't matter at all. I'm just saying here's 1, 2, 3, 4. No, my wife does.
No, not poker.
I try not to. I try not to play cards. It's not just I don't enjoy it, because my mind just starts going, because I'll see these 5 cards.
And you start thinking about math.
And I'll start thinking math, and I'll start thinking, oh, I got a pair of 9s, I can do this, this, and this, this. I got reds, I can do hearts. I start thinking it's not enjoyable because I start thinking math. For no reason, okay? So what I'm looking at here is by taking 5 cards, how many different ways can the 5 cards just be arranged out? So you have,
This is a terrible hand.
you got a pair of 10s and a straight.
Ass.
5,
This is
6,
a
7.
horrible hand.
Well, to be honest with you, start with a pair of 10s and she's got a pair of 9s. You have a straight going with your 5, 6, 7. That's really nice. That means you could try and get an 8, 9, or you can try a 4, 3. So you can try and get a straight, which is a really hard thing to get.
In what game?
Don't forget
Poker.
that
Or you've got a pair. You've got a pair of 10s. So what you're looking at is you start thinking about, all right, what are more common? Pairs and things like that. And we'll get into all that of the probabilities of when you start thinking about what's available. Now, obviously you don't show your hands, so we don't play like that. So that's kind of where we're at. Now, when we're dealing with this, if order doesn't matter, if order doesn't matter, we use what's called a combination. Yesterday we had the NPR, today it's the NCR.
I just played you.
It's a little bit, it has a couple more things to it as opposed to a permutation. Okay. Where order matters. When order doesn't matter, it's just a combination. You're just selecting objects. How many ways can I select 5 cards? Well, what I'm looking at doing here is if I'm going to select 5 cards out of a deck, there are 52 cards. I'm choosing 5. What that means is how many different ways can I arrange 5 cards out of a deck of cards? How many different poker hands are there? That's what that means. There's lots. Many.
No.
So I can type 52 alpha window 8, choose 5, and there are basically 2, 5, 9, 8, 9, 6, 0. There's basically 2.6 million different poker hands available. Yes, ma'am. What do you got?
Never mind.
So of those poker hands, here's one of them.
I played that.
Here's another one of them, and so on. That's kind of what this does. Okay. Now, bless you. Oh, they're about to sneeze. You had the eye water. You're like, all right. What I want to also think of is
Do you know there's more ways to shuffle a deck of cards than there are atoms?
I mean, you could really, if you really want to, you can shuffle a deck of cards, put it through a shredder, then reassemble the cards, and then get.
because if you're shuffling a deck of cards, isn't that just 52 factorial? Because there's 52 cards you can move around.
No,
with
it's
this.
like ways to shuffle a deck.
Oh, gotcha.
So like,
I didn't see
there's
that
the
one.
classic way, you could just kind of put them in a pile, put them all back together, put them through a shredder, then put the cards shredded back
More ways to
together.
shuffle a deck of cards than there are atoms on it.
Now, oops, wrong button.
So I only need to win 2 more.
No, you're not right. He's not talking about shuffling. He's talking
Oh, do
about
I get home field advantage? Still sitting there.
Yeah, your home court.
So here's where I want to think of. In how many of these hands, of those 2.6 million hands there were, how many of those were all 5 cards the same suit? When you have all 5 cards the same suit, it's called a flush. They're all the same. Okay? That's called a flush. So we had 2,598,000 something.
960.
Yeah, no, you're right. It is 2 factorial.
Oh, okay.
But like, it's 80 something with 67 zeros.
So 52 factorial
It's overtime.
is 80, and then
Well, it's, here, wait, when I put it in the calculator, it said,
Alright, I got
8.065, blah, 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 to the 10 to the 67.
all right. So
Times 10 to the 67. That's how many ways to shuffle a deck, like to arrange a deck of cards.
Oh.
So it says like when you pick up a deck of cards, you're almost like positively like 100% holding like an arrangement that's never like, existed before.
How many zeros are there?
44.
Your fault.
Oh, that's when we do. I think you miscounted, guys.
If you start counting, it'll mess them
Why
up.
is there 6 there?
5, 7, 8.
Yeah. There's 68. I was going 6, 67, 68. Everybody is 6. So you said 68 or 67?
67.
Okay.
There's that one random 6.
Because I was saying in my head 61, 62, and I,
Wait,
That's
that was
fine.
four. I wanted 4.
We gotta count them all out.
How many atoms are there?
I know 2 atoms.
That was not.
Yes, it was.
I thought it was funny.
Come on, that was good.
These knucklehead kids.
Oh my god, that's probably like tripping you out.
This is really tough. I'm not lying. This is tough to do.
Wait, can you say that number?
That number.
Okay, well, the one on the board.
7
2.
over 8.
The big one on the board.
2 is
2.
larger than that.
That's not big.
It is. It's larger.
3.
The one that goes
Alright,
across
now we're
both
gonna
boards.
count.
2.
2. There's 2.
3 is
The one that starts with, I think it's an 8.
80. 600. And it's a very stupidly large number.
8.
So yeah, when you really start, and that's the idea, as you start thinking about the enormity of numbers. I mean, seriously, think about how long it would take you to count to 2.598 million. 1, 2, 3, 4, 5, 6, 7. And then you start saying 986,433, 986,484, 986. This takes longer. You'd be counting to that for years.
Yeah, it says anytime you pick up a well-shuffled deck, you're almost certainly holding an arrangement of cards that has never before existed and might not exist again.
So, and that's kind of cool. That is really cool. So here's what we start doing with the deck of cards. We start thinking about the idea of, in how many ways can I be dealt all 5 cards being the same suit? Which means you have to start thinking about how that can occur. How many suits are there? There's 4 suits. So there are 4 suits in a deck of cards. You're going to choose one of them. Of that suit, how many cards do you want? How many cards will you be dealt? How many cards are there in that suit? 13. So what happens here is we start compounding these things. You have to pick the suit. So you pick the suit, and then of that, you need to multiply that by, well, there are 13 cards within the suit. You want 5 of them. So you have multiple parts going in there. Okay? So you pick the suit, and then you want 5 of that suit. So if you do 4C3, 4C1,
This is 2.5.
it is a lot of math. And you never would have thought that, playing cards, you get 4, and then 13 alpha window 5. So 4 times 1287. That means there are 5,148 different ways that you can be dealt all the same cards within the same suit. So it's a little bit less than what we have here for ways of being shuffled out. But then if you start thinking about probabilities. Probability, remember, is the favorable divided by total outcomes. For example, rolling a die, 6-sided die, the probability of a roll of 3 is 1 out of 6. The probability that I flip this card over and it's an ace is 1 out of, well, how many aces are in the deck? 4 of them, how many cards are there? So it'll be 4 out of 52, 1 out of 13. So I have a 1 in 13 chance of flipping a card over and it being the ace. That's where gambling comes in. It's where blackjack comes in, about knowing what's in the hand, what's out in front of you, about probabilities of what's available. It's where math becomes fun. Okay. Now, here, if we have 5,148, so this equals 5,148. There are 5,148 possible ways to be dealt a flush. It doesn't happen very often because put that in terms of a probability. Take 5,148, divide that by 2,598,960, and that will tell you the probability of getting a flush when you just are dealt it straight out.
Oh, that's great odds.
You have basically a 1.9% chance of getting all 5 cards when you after shuffle being dealt out all that.
You're on 8. 3, 5, 9, 8.
Oh, so it's sorry, it's even worse.
Oh, now I really want to know what the probability is of being dealt like a perfect hand in euchre.
And you can do stuff like that.
Perfect hand in euchre.
Perfect hand in euchre is like the 2 bowers and then like the king and then
Less than you have a 0.19% chance. So the theoretical probabilities of doing that, that's why having a flush is worth much more than having 2 pairs. That's why having a straight flush is worth more than having a flush. A straight flush is numbers in consecutive order of the same suit. And you start getting into that, it gets crazy.
Why the lottery steals your money.
Exactly, and that's where all this comes from. Okay, that's where this brings itself to. What was the other one that I had here? Oh, that's not the right one. But I had that file open. Worksheet for this? Where'd it go? Oh. Let's do another. How many different ways can I be dealt 5 face cards? How many different ways can I be dealt 5 face cards? Well, how many face cards are there? There's 12 of them. There are 3 in each suit. All right, there's 3 in each suit, which gives you 12 total. So if you have 12 cards to pick from, how many do you want? 5. So out of that 2.6 million, there's only that many ways to be dealt 5 face cards. Again, this doesn't happen very often. Right. So the
How did you do that?
alpha window 8. Okay. This is where all this stuff comes into play. All right. What can get really interesting? Let's leave them up. Just do those 5. We're just counting.
Yeah, that's fine.
This is 12.
12 2. We'll get into more of the counting stuff about ways and things to be arranged and things like that. And next week, I figured this is. What's that? I have to get these stuff.
I have to get it. How much have you ever? 9.